Hello, everyone. So we have 2024 National Target Round question number 2. Even though this is number 2, a lot of people actually couldn't do this problem on the test. So let's see what we have. So we have a trapezoid, and AB and CD are parallel, and M is the midpoint. So let's highlight this part. And the angle BCM is 90 degrees, which is given right here. And we have AB and BC is 7, CD is 18. What we want is BM. Okay. So like, since we are given this is a midpoint, it's good to ask question how we can use that. So one of the good things we can use about the midpoint is using that to kind of build some similar triangles. If I extend the MC in a way that I can extend AB, I will actually get the similar triangles. So if you cannot really see this immediately, which I recommend you to a little bit more similar triangle stuff. So this is really a common approach. So since we know this is the intersection of this line and AD, then the triangle right here and the triangle right here is similar because you have a lot of same angles, like the angle right here is the same as this one because of the parallel lines, alternate interior, and the same idea, this angle and this angle are equal, so we have the vertical as well. So why this is important? Because since this is the right in the middle, AM divided by D, like MD is 1 to 1, that means if I call this is T, TA divided by DC is also 1 to 1, so which is why this is 18. So, but how this is going to be useful, right? We know that TB is now 25 and then BC is 7, which will tell us TC is 7, 24, 25 Pythagorean triples. So if you do remember, that is really nice to have, or you can just use the Pythagorean theorem, right? So which is why that will be just half of 24. This is also half of 24. So now we have 7 and 12, and you can just use the Pythagorean to find the MB. So if I kind of go ahead and do that, so you will get the 7 squared plus 12 squared is MB squared. So 49 and 144. So if you had this 50 and then this is 43, right? So that will be 193 is equal to MB squared. So you can try finding if this number has any divisor. You need to check any prime number that is lesser than square root of this number. So this is close to 196, which means I have to check every single prime all the way to the 13. So 2, 3, 5, 7, 11, and 13. If I check all of these, so this number is not divisible by any of these. So meaning that that's a prime number. So the answer should be square root of 193. Which is, we are looking for a radical form. So even though that is not perfect number we did expect to see, because we did have some special like Pythagorean triples. So that was something maybe not expect anyway, but that's the answer for number 2. So let's look at another geometry problem on the target run, which was number 7. So basically we have a cone and the height is given as like 4, the diameter is 6, so this is the radius is 3. And we have 2 points, P and Q, and an angle in between the arc PQ is 150. And the question telling us there is a path from P to Q without really going through the circumference, right? Excluding the base. What would be the shortest distance that we could have? That's the question. This is also common types of question. If you kind of don't know how to deal with these kind of stuff, so it's also nice to review the path around a cone or even cylinder. So these are also special question that we've seen a lot. Okay, so in order for us to kind of deal with these, it's better to find the net of the cone, which is why I will try to kind of see how that looks like. But if I try to get the net of this cone, so I should remember the circumference of the cone the base of the circumference of the base is gonna be the arc that we are gonna get in the net. So if you kind of don't know that, so you can try to read some of the videos about that. I will just attach one, especially for the proof portion. But it is good to take a look if that is not clear for you at this point. Okay, so what I'm trying to say, if I take the circumference of the circle, which is basically 2 pi r, and then the r is 3, this circumference will be equal to the arc of the sector that we are going to get when you open this cone. So since we kind of don't know how large that our sector will be look like, so I'm going to just say the central angle of that sector is going to be alpha divided by 360 times 2 pi times radius. The radius of the new the sector when you open this guy will be actually this slant height, which is 3, 4, 5. So this distance is just 5 units. So then the radius of the sector will be 5. And if I kind of cancel these guys, and then this is going to be divisible by 5, 72. So alpha is 216. Meaning that if I want to kind of draw the net, right? So it's going to be something like this. It has to have a 210 degrees as the angle. So I'm trying to visualize a bit. So this angle, it doesn't really nice looking, but it's going to be 216 degrees. And when you open this, when I say opening, if you just cut it from this side or this side and open it, so you will get this image. And if you don't kind of convinced, then try to get a cone with paper and then cut it and see if that's going to look like. But the video I'm going to attach is going to actually show you how you can play with this on GeoGebra. Okay. So anyway, so this is the picture, and the 5 is the radius of the sector, because that will be the slant height will be radius of the sector when you open it. Okay, but the question is, when you have P and Q, how this is going to be related. So we need to find a the path like this one. But let's say this is a point P, and we know that this is 216 when you open completely, but this is 150 degrees, not the 360. So which is why I'm going to take the 150 divided by 360 just to see what fraction of the circumference that I'm actually interested. So when you have the full circle, that will be 360, which means from this point all the way to here will be just the P to Q if you just had the full circle. But we are going to do this only to 16 degrees, because when you open it, so you're going to get this fraction of 216 degrees. So if this part is not clear yet, so just pause and think about the reasoning and see if that makes sense. So what I'm trying to say, when you open the this cone, the distance between P to Q is going to be part of this arc, but this arc complete is going to be corresponds to the circumference. But we just need to know what would be if I just take the 150 degrees out of 360s. Okay, so I hope that is now better. So you can cancel these guys. So I can divide by 3, which is 5. That's 12. And we can use a calculator, but I think we are good so far. So I can divide by 3 and divide by 3. So that's going to be 4, 18. It looks like 90 degrees. So meaning that when you take the, let's say this is Q. When you take the P and Q, so the angle in between those two should be 90 degrees. So it will be something like this. So this is 90, and then the remaining has to be 260 minus 90, which we don't really care. So since we are looking for the shortest path, so it has to be P to Q, the straight path. So if you just make a straight line from there to there, so you have a nice right triangle. And I do know the radius of this sector was 5. and this is also 5, so that means this is 5 root 2. If you plug into calculator, so you will get 7.07 approximately, and nearest 100. Okay, so I hope that was clear. So this was kind of challenging. At the same time, it wasn't too bad, especially for number 7. So I'll see you in the next video.